Bum 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 bum.
Tomatoes?
Hello, and welcome to the video for C++ with blueprints, converting a blueprint function to C++. If you watched the previous video, this one may seem very familiar, and it's supposed to. We're basically going to take an existing blueprint function, convert it over to C++, learn some more API documentation and things that we might run into, and then show how to expand upon it. So let's get started. So this one's pretty simple. Whenever I do a example video, and I'm showing it off, I show off something explaining it. So for example, if it was a line trace helper, I would select the line trace helper widget. And on the bottom left, you'll see, hey, it's a C++ line trace helper. So it's useful so the people who are watching know what videos they're watching. And all this does is add a widget to a screen and set different input modes. But I made it a macro, or in this case, a blueprint function library to make it quicker. I just, boom, it's one node, we're good to go. So if we look at it, we take in a widget, we do some validation. If it's not good, we stop and we put an error on the screen. If it is good, we throw this onto the screen after we create it. We set the appropriate input mode and the mouse cursor mode, and we're good to go. Now, the disadvantage of this one is I have to create 3 of them. And this, you can see in this project, I've only created one called setup game mode only, which is right here, input game mode only. But if I wanted it UI mode or the game in UI mode, I would have to create 2 other ones. Now if we close down this for now, and we hook it up to here, and we hit play, it's the exact same thing. The difference is this is my C++ code, and this is my blueprint code. Functionally, they're the same, and they look the same even down to the tooltip, but one is C++ and one is blueprint. And down here, I have a more advanced version where it does the same thing with the input for the widget, but I can also change the mode in one drop-down. So I have one node, and I can select the type of input mode I may want, like in this case, game and UI, rather than just game only, and not having to have 3 different ones. So we're going to look at this code, and we're going to convert it over. So let me open up my C++ code here. If you're doing this or following along, or you want to do it yourself, you can create a new blueprint function library, because that's what we're going to be using, or just add on to your existing one. In this case, I created my own. One is for personal stuff, like this for the setup. The other one is for things I share, like maybe game specific, or project specific stuff. So in this case, I have a header file and a C++ file. I have an enum I've created called UI mode. So it's my UI mode enum. And it's got 3 different values in here for my UI only, game only, or game and UI. You can see how this is declared here, just like any other class or property or function. It's got some values inside of the macro, and then it's got some meta stuff for displaying in blueprints. All of that stuff, it's all in the documentation. It's all in our API programming guide. U functions, U properties, U classes, U enums, U structs, they all have that information exposed, and you can all see it in here with all the valid values. We have our U class, and I have down here my 2 U functions. One of them is my generic one for my game only. The other one is my more, well, actually, let me rephrase that. One is more specific by being game only. The other one is more generic by allowing me to feed in a mode as well. Now, the only real big differences with these ones is we want to be able to pass in a class, and we want to be able to pass in a class of a widget, and we want to do something with that widget. So that introduces a couple funky things in here. Just like before, we need to pass in our world context object so we know where it's being called from. So nothing different there. You'll notice I don't have a const on this one. Technically, I'm allowed to change this because I'm not passing it as const. And technically, because I have no outputs, because you'll notice there's only inputs, the engine doesn't need to know that these are consts. However, this is one of those cases where you have certain programming paradigms, certain programming routines that the engine uses that you should probably follow. So to have this properly, it would probably be better to have const in front of these, but you'll notice it does work without. And since we're not learning C++, We're just learning how to use C++ with blueprints. We're just going to make it work as is. Now this next one is the T subclass. T is a template that basically means we're going to return back a subclass of class user widget as the name widget. So we want the class, and this is all helper code to get us the class. We don't want the widget because we're going to create the widget out of the class. If we open this up, and we'll go to definition, this opens up our code, and here's our code for doing that. Now, if you followed through in the previous video again, which hopefully you did, really, really simple. What do we need to do? We look at our code. We'll open this up. We got a couple things. Is valid class, targets Kismet system library. Branch, branches are ifs. Create the widget. Well, where do we create the widget at? We'll have to figure that out because it's not giving me any pop-up. Add to viewport. Okay, that one's easy. Targets the user widget. No problem there. Get player controller. Oh, gameplay statics again. Targets the widget. Show mouse cursor. Well, it comes off the player controller, so hopefully we can figure that one out. Print string. Kismet system library. So we have the declarations for all of these. We can look through our values. We can look through our API documentation. And we can find where every single one of these things are. So by doing that, we end up with this code here. We grab our player controller because we need the player controller in order to set the input mode and to set showing the cursor. So we grab that first thing. Now you'll notice something here. I'm using a lowercase PC for player controller. If you take this exact same code and you were to look through it for the Unreal Engine code base, you're going to find they're going to use capital PC. That is their coding standard. The whole point of coding standards is to keep it consistent. If I was going to take this code and have to integrate it with Unreal Engine's code base, I would capitalize my code to keep it standardized. This is my code base. I'm used to doing it this way, and so I'm going to do it this way. Either way functionally works the same. It's just, again, a standard. You'll see me switch back and forth as well just to annoy you guys because, maybe you're paying attention, maybe you're not. Really simple. Gameplay statics, get player controller, takes in the world context object and the player index. I'm always doing this locally. I'm always going to force feed in 0 because I always want to do this just for my stuff. This is mine. So I feed in 0 every time. And we feed in that world context object again. And it returns back a player controller. And it returns back technically a pointer player controller. Cool. Boom. Line. Done. Next thing is valid class. Kismet system library. We already determined that looking at the blueprint code. So we say, hey, system library, is this a valid class widget? So did I actually put something in there? And then we use the not operator, which, again, blueprints, not operator, should know the stuff. It flips it. So if it's not a valid class, we're going to want to give an error. And this is really simple. Grab the system library again, print string, takes in the world context object. You can see it all right here, this long, long thing. Takes in our error, what we want to do with it, what color we want to put it out, and what duration. If you want more information on how that works, you either read the code or, Kismet system library print string. This will probably be one of the last times I point this out again, but that's what we have our search bars for. This is what we have our API. I pasted that in the wrong one. Darn it. I want to make sure I'm keeping that consistent in case I need to bring that reference back up. There we go. So Kismet system library print string. And then right here, C++ API. Kismet system library, and there's the Kismet system library print string. And, we'll just cheat. We'll go back here, and we'll check out print string. And here we go. Print string takes in these things and tells you what they are, and that's exactly what we're using here. Easy enough. I do it 3 times. Well, 2 times, sorry. Apparently I can't count because I have it here. Print out the error, print out where we get it from. In this case, I'm using the world context object. So we need the world context object to print the string. And then I'm grabbing that world context object and asking it for its name so I can print that name out so we know where this error came from. And then we are calling quit game, which again needs certain things, player controller, how we're quitting, etc. All again, API, copy paste, you're good to go. That's just the way it works. Take the code from blueprints, copy paste it into C++, really simple. Once we're done with this, if we didn't fail out, if we've got a good class, then we're going to make a new widget using create widget. It takes in a user widget for the type, and then a player controller that's going to connect to, and then a widget, which is our input here. So we took in our subclass widget, create widget wants that subclass, and there we go. And then we take that widget and we add it to the viewport. And then we set our input mode to game only, and then we don't show our cursor. All this code is like one-to-one code in here. Player controller, show mouse cursor. Player controller, set input mode game only. Set input mode game only, taking in the player controller from the widget blueprint library. So you notice this is the widget blueprint library calling set input mode game only. And if we go over here, set input mode game only, you'll notice it says target is widget blueprint library. Even though it takes in a player controller as an input, that's not the target. It needs a player controller to know which input to set in. So keep that in mind. Just because you see an input, it doesn't mean it's what it's targeting. That's why we kind of want to read our little targets in our descriptions. And even if we didn't know, set input mode game only, gee, are we going to look at the documentation? I don't know. In this case, I'd look at the code itself and, set input mode game only and see what comes out. Nope, we couldn't find anything. So maybe set input mode game only. Nope. And this is where you start searching. Oh, look, I found set input mode with space game only. Up, set input mode. Here we go. Begin play, set input mode, F input mode, game and UI. Oh, look, U widget blueprint library, set input mode, game only. Hey, set input mode, game. Yeah, so you just read through the code and just start slapping stuff in here and see. That looks familiar. Blueprint library, set input mode, game only. Blueprint library. Wow, that was really hard to find. Just being sarcastic, pointing it out, it's not that hard. And that's the entire code. That right there mimics our code right here. Now, whether you think it's readable or more legible, again, all personal preference. There's no bias. C++ is not better than blueprints. They work hand in hand. In this case, we are trying to make things just simply flow a little better and use C++. Looking at this next one, you can see this giant little booger here. This is the one that takes in the other item. So our top part's pretty much going to be the same, except I have a better display mode because I want to use the and symbol. And then we have our word context object, again, subclass of widget, and then we take in an enumerator called mode. Simple enough. We look in here. This whole top part is the same all the way up to here. The only difference is we're not setting a specific game mode. We are using a switch, which switches in blueprints, on our mode that we're passing in, which is our enumerator for our UI mode, and then doing it appropriately, setting the appropriate input mode and show mouse cursor. So this is pretty much our only extra code here. This right here allows us to replace this code and allows us to switch based on our input. Now, you would not be able to get this working properly the first time because of some issues. So here's the issues you're going to run into. You'll notice this is something we have new in here, our user widget. If we were to, let's find, this one's probably a good one, create widget. If you were trying to create, well, here. So if you were to remove this one, include user widget, and you tried to do create widget, you're probably going to run into an issue because it doesn't know what a user widget is. It doesn't have any of that information, and you're going to get red squigglies at some point whenever Visual Studio decides it's going to do its thing. Once you get the code fixed, it's going to run fine, but it's going to give you a really weird, really bad, really funky error inside of Visual Studio saying it can't find the appropriate stuff. And the error is not going to point anywhere near this stuff. This is where our API documentation comes in handy. So it's our user widget, and we know it's the create widget. So let's find our API code, and we'll call it what? Create widget. That probably needs to be spelled right. Create widget, and find some C++ API, and here's create widget, and that's not what we needed. That's a blueprint. Why do we get a blueprint when we did C++? I don't know. That's not helpful. Well, here's the user widget. Okay. So here's our user widget and all the stuff we need for a user widget. And here's the construction script and adding the viewport because we needed that. If we go to the bottom, we have our header. So now we know it's in the user widget header. but you'll notice this module. This module is UMG. The UMG module is required in order for us to actually use this information. So at one point, Unreal Engine broke things apart in order to make things compile faster and compile easier and stuff like that. So if we were to go into our project and we were to go into our source and we were to look at some things in our source, we're going to find our issue. So here's our build file. So this is why this one was important to do, even though it's kind of the same as the previous video. If we open up our build.cs file, I'm going to open up a notepad because why not? You're going to find this information in here. Now, by default, your default build.cs is not going to include these files, and it's not going to include this. You'll notice this says uncommon if you're using Slate UI. Slate is the backbone of the UI system and powers the editor and the UMG system. These are disabled by default because if you're not using them, it's not going to load up the extra resources. So in order to use UMG, you have to uncomment this, and you need to add in UMG as one of the public dependency modules. Remember how before we were looking at some other things, and I said, oh, you don't have to worry about it because it was in Engine or it was in Core for the module. So like, let's say, for example, get player character and spell that right. Player controller. Okay, cool. That's easy enough. We look at player controller, module engine. Module engine. These are all your default modules. So most of your things are going to work. So if you find a really weird crashing error, so you know what? Let's just do it. So we're going to get rid of that. We're going to remove it from our build.cs file. We're going to go back into here. It's going to say, yeah, you changed something. So we're going to go ahead and reload it. And then we're going to go and reload our CPP's example. We're going to go ahead and build CPP example. Now, you haven't had to do this yet, and I haven't shown you how to do it yet because, well, I haven't had to do it yet. Great, it's not valid for the target. That would be helpful if I actually change these things. So development editor, Windows 64. If you run into this issue, make sure you have development editor, Windows 64. And then try building again, build CPP, and it should go through. I expect it to fail, and I'll show you why again. I probably should have showed you how to build earlier, but all you had to do was hit the build button and it would have built. And we're running the editor right now, so we're getting can't do some of the debug stuff. But here is our error right here. Like I said, it's a weird one. Unresolved external symbol. User widget, get private static class. Unresolved external symbol, user widget, add to viewport. Unresolved external symbol. So if you get these unresolved external symbols, and you notice there's multiple ones in here, and almost all of them are referencing like the user widget, but like this one references the widget blueprint library, and this one's widget blueprint library. Once something like this breaks down, it just starts cascading to everything else. But if you run into an unresolved external symbol, something like this, there's a chance that the engine simply has no idea what you mean. So make sure you have the appropriate includes, and then make sure in here you have the appropriate dependency modules. So we'll add UMG back, and we'll save that, and we'll go ahead and reload, and we'll rebuild CPP examples. And once this goes through, well, apparently I put another error in here somewhere. Where did I screw up? Oh, that would help if I had put the appropriate in there. So let's try that again. See, got to make sure you put the right stuff. You don't have the right amount of commas or quotation marks or semicolons, everything's going to explode. And you'll never know why because it tells you some other error. So it's building it out, and you'll notice it went through fine. This one right here isn't really an issue because we have stuff open right now. So we probably want to close everything down and go back to our project itself and open it back up and rebuild it. I mentioned this before. You run into issues, something doesn't seem to work right, close down, reopen, I accidentally double click. So that's why we have that weird file right there. Let's go ahead and build our example file again. And this time it should go through and we shouldn't run into any issues. There we go. Build succeeded. And that's all you have to do to build your module. Now we're going to run into another issue. So we're going to go into debug and we're going to start debugging. And it should complain. Unable to start, blah, 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 blah. Can't file a file specified. Well, what's that mean? Well, at some point in time, our default project changed. It's trying, well, I don't know if you can, how well you can tell, but, well, let's go down here. The UE4 right here is bolded. That means whenever we try to debug, it's trying to build the engine. And you can't build the engine if you don't have the source code. You don't have the actual source code from GitHub. So if you run into that issue, find your actual project, right-click on it, and set it as a startup project. And what that means is whenever you're debugging, it's going to go ahead and try to run that project. So now that we've built out our change and we've verified that it's going to compile properly, we've added UMG in because we're using UMG. Now I can build my editor and we could see it running. But I'm going to stop it and crash it because we don't need it anymore. Closing out. That's pretty much it. That's the issues you're going to run into in regarding doing stuff like this. We introduced a new module, the UMG system, and we introduced the ability to pull in classes. But you'll notice all these things pretty much came from just copy pasting other existing stuff and making sure we use the right function meta tags and function properties and make sure we passed in the proper information. And we just did a lot of copy paste. We took our code, which I lost. Oh, because I closed down the project, of course. We took the code pretty much line by line and copied in here just like before, and then we resolved the issues. If you run into problems, refer to the documentation. 9 times out of 10, you're going to forget an include, or you're going to forget a module, or you're going to not have the proper signature or whatever you want. If you're copying and pasting, most of the time the error is going to tell you exactly what the problem is. But that's how we would copy from blueprints to C++ and try to resolve some of the issues we run into using other external modules.